Welcome back. I hope you're doing great. As a part of this video, we'll take an example to understand the dimensional and fact table. Let us say you are shopping in a retail shop or Amazon or any e-commerce website. When you go ahead and purchase some product, what and all will be there as a part of the product? First thing is you'll have a date on which you have purchased. Then you have a store in which you have purchased. Then you have a product which you have purchased. It can be a dress, it can be a coffee, it can be a grocery, it can be anything. The product can be anything. So how much of the quantity of that product you purchase, that will be another attribute. And what is the price at which you are purchasing that product is also one more important information. Then what is the amount you have spent to purchase the different products? So that is also one more important information, right? And also the transaction number is also one of the important attribute. So now while I am explaining all this thing to you, you may be wondering, all this data is there as a part of one of your transactional processing system as one of the RDBMS database. But what is it we are trying to do here? We are trying to create a data warehouse. When you are trying to create the data warehouse, we cannot really have all this data dumped into one table, right? That is where we are storing the data either as a part of the dimension table or a fact table in data warehouse. So, but the problem here is I have all this data as a part of one table. How can I put some of the data into the dimension table? How can I transfer some of the data into fact table? That is where we need to have a sense of what are the attributes which fall under the dimension table. What are the attributes which can be loaded to fact table? The usual high level thumb rule is whichever the data which is of text data can be a dimension. Whichever the data which is numeric, that can be a part of a fact table. Why is that? As we already understood, fact table has facts and measurements. All these numeric values are facts and measurements, right? Quantity. Once you mention how many quantities you have purchased, that is never going to change. Unit price at that point of time is not going to change. Whatever the numeric data which was captured on that particular day is never ever going to change. That is the reason it is a fact. So most of the numerical values can be considered to be moved to the fact table. So at a high level, we understood how can we classify the data from transactional processing to be moved into dimension table to be moved into fact table. Awesome. Let us extend this further. So here if you see, we have the same data we are representing in a table. So we have a text data, we have a numerical data, that is number. So wherever the data is numerical, that we can consider as a fact. Wherever the data is descriptive, that can be considered as a dimension. If you see here 10, 20, 30, 100, 120, 20, these are the facts, okay, are the measurements. We're considering them to be moved to the fact table. Now, what exactly is a dimension? Dimension will describe these quantitative numbers. Now, can you imagine a quantity without a store and a product? You cannot. In order for the quantity to exist, you have to have a store and product. Otherwise, this quantity and unit price will not have any significance. So, dimension are describing this quantitative numbers. So we can establish a relationship by store to the quantity. So now the whole data is there as a part of any RDBMS database. Based on whether it is a dimension data or a factual data, we are trying to move that into a dimension table or fact table. Now once we move a certain number of columns into dimension table and certain number of columns into a fact table, you got to establish a relationship between these two, right? That is where we can establish a relationship between store to the quantity. I hope it is clear how we can categorize the data in a transactional processing table into dimension data and fact data. Let us extend this with a one more important example. You can see here there are four tables: customers, product, store, and state. What are these? These are dimension tables. Why are these dimension tables? We say product ID, it is describing the product. Customer ID is describing the customers. Store, it is describing the store. State, it is describing the state. So in the center, we have a one more table called order. What kind of a table it is? No brainer, right? It is a fact table. So these are dimension 1, dimension 2, dimension 3, dimension 4. Why is this guy a fact table? Because you can see there is a order amount, order quantity. These are facts. These are measurements. So now what is happening here is we have a fact table with different attributes. Can we just have only fact table and start analyzing the things? We can't do that. We got to establish a relationship between this fact table and dimension tables. So what do we do here now is each of the tables should have a primary key. Like customers has a customer ID as a primary key, product has a product ID as a primary key. So the primary key of these individual dimension tables would become a foreign key of a fact table. That way, depending on the analysis what we are trying to do, we can always join the relevant tables and try to get our information. Awesome. We understood the dimension and fact tables with an example. Thank you.